Alright, a couple quick examples of how to solve a system. If I look at this, my first equation, that's definitely linear, so no x squared, no y squared. My second equation, we haven't talked about this form a lot, but I've got an x times y component, and this is actually going to be a hyperbola. So if I'm thinking about how these could possibly intersect, they could not intersect at all. They could intersect at one point, or they could intersect at 2 points, because I've got a line and a hyperbola. Well, in a lot of these cases, I'm just going to look at these and I'm going to say, well, looks like substitution would be a good option. So I can choose either one of the equations to get a variable by itself. And I actually like to work with this equation first. So I'm going to take that and I'm going to divide both sides by y. I just decided I wanted to get x by itself. So then I know x equals 4 over y. And that means that I can take that and substitute it in for x. So I'm going to go ahead and do that, and I get y plus 4 times dropped in place of x, 4 over y, equals 10. Now I'm going to simplify, do some things with some distribution here, so I'm going to y plus 16 over y equals 10, and I want to multiply both sides by y so that I can get rid of that denominator. Y squared plus 16 equals 10y. And now I've got a quadratic, so I'm just going to go ahead and get this equal to 0. And either I can try to factor or I can try to use the quadratic formula. It looks like this one factors nice. X minus 8, x minus 2 equals 0. So that means x could be 8 or x could be 2. So I've got two possibilities for x, so that means I need to go back to my equations and I need to match those and see what y would be. So I'm going to start with 8. So I'm going to use this equation. 8 times y equals 4. Looks like y equals 2. So my first point of intersection is 8 comma 2. My second point of intersection, let's see, what did we have for our second x possibility? 2 times y equals 4. Y equals 2. So my second point of intersection is 2 comma 2. Okay, it'd be a good idea to go back and check in my other equation, but for the sake of time, I'm going to go ahead and jump to my next example. So these two a little different. I've got x squared components, I've got y squared components. When I write them in this form, it looks like things work out pretty nice. I've got an ellipse, and I've got hyperbola, addition, subtraction. I'm going to use elimination or linear combination. So I'm going to go ahead and I'm going to multiply this equation by 3 on both sides so that my x terms will match. 4x squared plus 3y squared equals 37. 9x squared minus 3y squared equals 15. And I'm going to combine 13x squared equals, looks like 52. X squared equals 4. So that means x is going to be either 2 or x equals negative 2. So I need to go back and try both of those in my two equations to find my 2 points.